Hello guys and welcome back to another video. Today we are going to draw a polynomial curve. So we have a problem question here in which we will draw a polynomial curve of degree 4 that goes through the following points. We are given with 5 points with x and y coordinates, and we are given some parameter values, and we have to draw the polynomial curve, and in the second part we will draw the tangent vector of the curve when t, the parameter value, equals 0.5. First we will start by drawing the polynomial curve, and we will write the coordinate points here. Now we have to write the x coordinates and y coordinates separately. So first we will write the x coordinates from all the points. So we will write it as px, and we will write all of the x values from each of the points. And then we will write the y coordinates of these points. Now we will plot these points on our graph, and I'm going to give it blue color, actually a blue dot, and we will give it some marker size so that it's clearly visible. And we will set axis equal and hold on here because we want the points to be on the graph. Now we will write the parameter values. We will start with t1, and we will write each of the parameter values from t1 to t5 because there are 5 values here. So in the question we are asked to create a polynomial curve of degree 4. So that's why we will write the variables starting from degree 4 all the way to 0. And for x coordinates we are using variable a, and for y coordinates we will use the variable b. And we will also write the parameter value as t. Now we will write the 4th degree x and y equations. We'll just copy and paste it here for the y value. Since we have created both equations, we will now evaluate these equations one by one. First, we will evaluate equation x. And we will substitute every parameter value with each of the coordinates. For example, we have the first parameter value t1, and we will be making it equal to the first coordinate of the x value. And so for the second value we will use t2 and make it equal to the second coordinate of x value. And so on, we will do it for all the 5 values. To evaluate this equation we will use the solve function here. You can give it any name. I'm giving it a name of s. Now we will use the substitute function. It is used to solve the values and substitute them back into original equation. Now we will evaluate the y equation, and we will just copy and paste the above equation here because it's going to be same. We will just replace every x with the y. And every x coordinate with the y coordinate. Also here we will substitute x with the y and each of the a with the b variables. Now we have calculated both the x and y equations, so we can now draw the polynomial curve. To draw the polynomial curve, we will use function plot here, fplot, because hx and hy are both functions of x and y. And we will give the parameter values from t1 to t5 because that's the range we are looking at here. Now we will run this segment of code to check if it works. Yeah, now we can clearly see that we have the curve passing through all of these points. This is a polynomial curve. And we will also look at Hermite curve in this video in a different question, which uses the same methodology, but it offers more control and a cubic function there. So in the question, we are asked to draw the tangent vector of the curve when parameter value t equals 0.5. So first we will assign the parameter value t0 equals 0.5. And we will take the differentials of both of these hx and hy equations. It's required for the tangent vector. To draw the tangent vector, we will use quiver function here. Since we have to draw the tangent vector at t0 or when t equals 0.5, so we will use t0 here. And we will give it a black color so that we can differentiate it. Now we will run the section, and here you can see the vector in the black color and all of the points. So this is the vector when t equals 0.5. Now we will move to the second question, and which is quite similar to the previous one. But in this question we are given the 4 points and we have to draw the Hermite arc that goes through these points. And the parameter values are -1, 0, 2 and 3. And we have to draw the tangent vector of the curve when t equals 2. So there are some minor changes that we will do in the last question to solve this problem. First of all, we will write the coordinates because we are given 4 coordinates here, or 4 points. So we have 4 coordinates for each of x and y. And also we'll write the y coordinates here. And we will leave the plot function as it is. And we will change the parameter values as we are provided. As I told you, we have 4 coordinates, so we will write the third degree polynomial equation. So we will actually remove the 4th degree variables from here. And also our parameter goes from t1 to t4, so we don't need t5 here. We will remove every 4th degree variable and 5th parameter from each of the equations. And we will change the parameter from t5 to t4 because the given parameter is from t1 to t4. And we don't need t0 here because the point at which we are going to make the tangent vector is within our parameter. And now we will run the section. As you guys can clearly see, we have the curve provided by this equation. And we can also see the vector in the black color. The vector is at the parameter value t3 or when t equals 2. So that's all for today's video. Thank you so much for watching, and please like, share and subscribe if you find this video helpful for you.